Welcome to today's tutorial video on synthesis and decomposition reactions. Today what we will be talking about are specifically synthesis and decomposition reactions, but there really are 5 types of chemical reactions that we will be talking about. So the first two are synthesis, and we have decomposition. We also have combustion reactions. We have single replacement, and we also have double displacement. Okay, those are the 5 types. This video is going to cover synthesis and decomposition, and the other 3 we'll be talking about separately. What you will need to be able to do with all of these 5 types is to be able to identify the type of reaction, predict the products, and of course, balance the equation. Every time we write a reaction, we need to remember our 7 diatomic elements, which we know as Brinkelhoff, and how to write formulas for compounds. So let's get started with synthesis reactions. Synthesis reactions are chemical reactions in which 2 or more substances, usually elements, react to form one new product. And so the general form of what that reaction looks like is written as this. So I have A plus B is formed into AB, which is a compound. So these are generally going to be elements, but not always. We see examples where sometimes I can have 2 compounds that just form one bigger compound, but most of the time they're going to be elements. Not always. AB then is the compound. So some examples of synthesis reactions, I have the formation of water. So I have hydrogen plus oxygen forming water. I balance it like that. Another example is aluminum reacting with chlorine to form aluminum chloride. There we go. So these all fit into the form of A plus B forms AB as a compound. I have 2 elements that are combining to form one compound, and that compound consists of both of the elements. I don't have anything new showing up. So let's try a few examples here. I'm given a starter for my reaction, and I want to know what it's going to form. I have to write and balance these equations. So I have sodium metal reacts with chlorine gas. So I'm first going to write my elements. Sodium metal, the symbol for that is Na. Na is not one of my Brinkelhoff elements up here, and so it doesn't get a little 2 next to it. I have to check for that every time. So sodium metal, that's a solid, reacts with chlorine. Now chlorine is one of the Brinkelhoff elements, diatomic, so it gets a little 2 next to it. It's a gas, so I can put a little G after it. To form. Okay, now at this point, I need to recognize that what they're going to form is a compound. And if they're forming a compound, I need to make that formula correctly. I can't just put Na and Cl2 together and call it NaCl2. So they're probably going to form sodium chloride. That's going to be the combination of these 2 elements, the ionic compound. And so I'm going to need to know the charges on those. So, oops. Sodium is a +1, and chlorine is a -1. So +1 and -1 cancel out. I get NaCl. Ionic compounds are going to be solids when they form from their elements like this. And now I can go ahead and balance. So I'll leave the balancing up to you. We'll get the skeleton equation written down. Okay, let's try another one. Solid magnesium reacts with fluorine gas to form something. So let's see. Solid magnesium is Mg with a little s. It's not one of Brinkelhoff, so I don't get a little 2 next to it. Reacts with fluorine. Fluorine is one of the 7 Brinkelhoff elements up here. It's the F right here. So that does get a little 2 next to it. That'll be gas. to form. Okay, so the ionic compound here that magnesium and fluorine are going to form is magnesium fluoride. And so again, I need to know the charges for those. Magnesium is a +2, fluorine or fluoride is a -1, and so I need two altogether fluorides to balance out with magnesium. And so my formula for my compound becomes MgF2. Again, that's a solid. Okay, go ahead and make sure that that's balanced. Let's try one more together here. So I have aluminum metal reacting with liquid bromine. Aluminum is Al, solid. It's not one of Brinkelhoff. Reacts with bromine, Br. Bromine is one of year 7 diatomics up here. It's the first letters. So that gets a little 2, and that's a liquid. To form. This is going to form aluminum bromide. Okay, that's the ionic compound that those two are going to form. So again, I need to write down my charges. I'm not just going to put these two symbols together and call it my compound. I have to think about how that's going to form. So aluminum is a +3 and Br is a -1, and so I need 3 bromides all together, and so my compound is going to be AlBr3. Solid. Okay, so go ahead and balance these 3. And then what I want you to try are these 4 on your own. Okay, so it's telling you what the product is for each of these. Go ahead and write the complete reaction like we did up here. Try to put in your states of matter if you can infer what some of them might be or look at a periodic table. And then, of course, balance the reactions at the very end. Okay, you try those and we will move on to decomposition reactions. Decomposition reactions are basically synthesis reactions in reverse. So what is happening in decomposition reactions are we have a reactant, which is typically a compound, breaking down into 2 or more products. And so this is my general form here for a decomposition reaction. Here I only have one reactant. This is my compound, breaking down into its constituent elements. And again, I would know what the formula for the compound is, or if I didn't, I would be able to write it. And then it would break down just into its elements. Again, I would have to pay attention to Brinkelhoff. So examples of this, I have water that might break apart into its elements, which would be hydrogen and oxygen. And then, of course, we can balance that. Another example would be mercury oxide breaking down into mercury metal and oxygen gas. So balance that. So these fit into this form here. So AB is my compound right here, breaking apart into its 2 elements. Okay, so let's do a couple of examples here with something decomposing. Of course, we'll balance the equations, and we'll make sure that our formulas are written correctly, and we'll look out for any Brinkelhoff elements. So I have solid lead 2 oxide decomposing. Okay, so lead, Roman numeral 2, oxide. So lead is going to be a +2 because of the Roman numeral 2. Oxide is O -2. And so I write that formula as PbO. And that's going to be a solid. It tells me that. It's also an ionic compound. And that's going to decompose. That's my clue in the problem that there's only one reactant. It's not reacting with anything else. So lead oxide is going to break apart. Well, what is it going to break apart into? It's made up of lead and oxygen, and so I'm just going to separate those. But now I have to pay attention to if any of them are diatomic. So lead is going to break apart by itself. Lead is not one of the 7 diatomics, so it's just going to get a little S next to it. And then I'm going to have oxygen. Oxygen is one of the 7 diatomic elements, and so it's going to get a little 2 next to it. That's going to be a gas. Oxygen is typically going to be a gas when it's released like that. And now you can go ahead and balance that reaction. Okay, we'll try one more here. Aluminum nitride. Okay, so I have aluminum, which is a +3, nitride, which is just nitrogen, with a -3 charge. Okay, so +3 and -3, those are going to even out, and so I get ALN. That'll be a solid. Okay, so what is that going to break apart into? It's going to break apart into its elements. I have aluminum, which is not one of my 7 diatomics. That'll just get a little solid next to it, plus nitrogen, which is one of the 7 diatomic elements, so that will get a little 2 next to it. And that'll probably be a gas also. All right, then you can go ahead and balance those two. So the main thing to remember with decomposition and synthesis reactions is they're kind of opposites of each other. They're reverse of each other. So that's why we're doing these together. Down below here, we see some specific guidelines for decomposition reactions. And I put these here with decomposition, but the same is also true for synthesis reactions. I would just reverse it. So the main ones that I've been showing you up until this point are the first example. Binary compounds break down into their 2 elements. So binary, remember, means 2 elements. So another example like this, I have sodium chloride that's breaking down into sodium metal and chlorine gas. All of the examples that I've given you on this page have looked like this. But there's also some specific examples that aren't always easy to figure out on your own, so that's why I'm giving you a few of these hints. If you were to start with any of these general forms for your reactants, you would need to know what they break apart into. And so anything with a carbonate in it is going to decompose into carbon dioxide and a metal oxide. And again, these are just harder to figure out because they don't break apart into elements. They break apart into smaller compounds. So I'll just leave these forms here, and you can read these and study those examples, but be ready to look out for some of those when we practice the next day in class. So now I want you to try these 3 on your own with decomposition reactions, and some of these might be one of these examples. So see what kind of general form it fits into, and then see if you can predict the products for that. And then, of course, balance your reactions. If you're struggling with the balancing, go back and try to really make sure that your formulas are written correctly. Okay? So we'll try this on your own, and we'll do the synthesis reactions on your own, and we'll see you back tomorrow in class. All right? Bye.